All right, welcome back to the lessons on quadrilaterals. Last time we looked at 7 types of quadrilaterals, very specific quadrilaterals on page 93 of our notebook. Today, we're going to dive into one of the bigger categories of quadrilaterals, and that is parallelograms. So on page 95, if you want to open up, we're going to talk about all the properties we have for parallelograms. All right, so we're on page 95 again. And this is properties of parallelograms. Okay, so a parallelogram is a quadrilateral, which means it has 4 sides. And more on that, it has 2 sets of parallel sides. So by definition, a parallelogram is a quadrilateral with both pairs of opposite sides parallel. Okay, so a picture of that would look like this. We got A, B, C, D. Okay, we'll put a little arrow on that one. So those 2 are parallel, and the top and bottom will also be parallel. And we can call this parallelogram A, B, C, D, or we can use the parallelogram symbol and put A, B, C, D. So you got 2 options. And with the parallelogram, we have 4 properties, 4 very specific properties that we're going to outline. So there are 4 things about this that are true other than the parallel sides. So property number 1, if parallelogram, so if you have a parallelogram, then opposite sides are congruent. Okay. Specifically in this one, your opposite sides are congruent. So AD segment will be congruent to BC segment. And then you could say DC and AB are congruent. Number 2, if you have a parallelogram, then opposite angles are congruent. Okay. So those are angles across from each other. So angle A and C are the same. Angle D and angle B are the same. So angle A is congruent to angle C for one example. So your opposite angles are the same. Your opposite sides are the same. Number 3, if you have a parallelogram, then consecutive angles are supplementary. Which we've talked about this before when we did consecutive interior angles. Okay, if I cover this side up, here are my parallel lines, here's my transversal. These two angles right here are supplementary, meaning they add up to 180. Okay, so here we have measure of angle A plus the measure of angle D equals 180 degrees. But I can use any two consecutive angles. I used A and D. I could have used D and C, or I could have used B and C, or A and B. Okay, any two angles that are right beside each other will add up to 180 degrees. And our last one, number 4, if you have a parallelogram, then the diagonals bisect each other. Okay, so I'm just going to draw an additional parallelogram down here. Okay, and we look at the diagonals here and this diagonal here. Now they bisect each other, which means that this side and this side will be the same, and this side will be the same as this side. Now, all 4 of those sides may not be the same, but whichever ones are on the same segment will be the same. Okay, so the diagonals will bisect each other. I'm going to do 2 examples of using these properties. So we're going to just take the bottom and split it in half here. Okay. And draw a picture. There's my parallelogram. A, B, C, D. So it says that this angle right here is x plus 3, and this angle down here is 2x minus 7. Okay, so I've got my parallelogram, and we're looking at opposite angles. So if we look up here in the properties, it says the opposite angles are congruent. So these two angles have to be the same. So x plus 3 has to equal 2x minus 7. Okay, so like with the triangle stuff, we'll just have to solve for x. Oh, excuse me. Actually, this one says find the measure of angle C. Okay, so we're actually looking for this angle up here, okay, which is not tied to these. Okay, but we're going to find x first. So I've got this set up over here. We're going to subtract x, so minus x. So 3 equals x minus 7. Then we need to add 7. And 10 equals x. Okay, so if x is 10, if I plug 10 in here, I get 10 plus 3, which is 13. So this is 13 degrees, and this one down here is 13 degrees. And I need to find C though. But I know that from this third property, consecutive angles are supplementary, meaning if they are next to each other, they add up to 180. So I know that 13 plus C, whatever angle that equals 180. So I'll subtract 13. And the measure of angle C equals 167. And I could have done this angle, 13 plus C equals 180, it'd be the exact same. Okay, so dealing with angles, opposite angles are the same. Angles right next to each other equal 180. Okay, our next example just says find X. With this parallelogram. Two, three, four. Having this graph paper really helps doing these. You can make them look really nice and things just become much easier. Okay, so with this one, they actually give us the diagonals. You see there's that diagonal and there's this diagonal. This one equals 3x minus 12. And this one is x plus 4. Well, if we look at this property 4 here, it says if a parallelogram, then the diagonals bisect each other. So these two things bisect each other, making this side the same as this side. So 3x minus 12 is the same as x plus 4. And we just have to figure out what x is. So I'm going to subtract x from this side. Get 2x minus 12 equals 4. I'm going to add 12. 2x equals 16. Divide by 2. And x equals 8. Okay. And then I could plug that in. I could just plug that in and find the length of each one of those sides if I wanted. Let's see, 8 plus 4 is 12. So this is 12 units and this is 12 units. Yeah. All right, that is going to do it for properties of parallelograms. I will look for a practice for you so that you can work on finding some angles, some diagonals, maybe the side lengths. Okay, maybe I give you some outside lengths of each one. And then the next lesson we'll go on to rhombus, and then we'll just go down through each one of them. If you have any questions, feel free to reach out. As always, thanks for watching, and we'll see you in the next one.